At first glance, the mangrove swamps look lifeless. Thick brown water barely moves. The air feels heavy, sticky, and still. Roots from towering mangrove trees twist into the mud like giant claws, locking the land and water together in a messy, unstable balance. Nothing about this place suggests comfort or safety. It looks like the kind of environment where survival itself feels like a mistake. And yet, this is exactly where one of nature's strangest contradictions quietly unfolds. In what appears to be nothing more than shallow, murky water, a fish does something that feels almost illegal. It rises from the mud, lifts its body upward, and pulls itself onto land. Not for a few desperate seconds. Not because it was forced there, but because it chooses to be there. This is not a dying fish gasping for air. This is a fish that lives here. The creature is called a mudskipper, and everything about its existence challenges what we think we know about fish. Fish are supposed to stay underwater. Their bodies, their organs, their entire design depends on water. Remove a fish from water, and the story usually ends quickly and badly, flopping, gasping, suffocating. That is the image most of us carry. Mudskippers destroy that image completely. They crawl across wet mud as if it belongs to them. They pause under the sun, lifting their heads like tiny dragons surveying their territory. They fight. They chase rivals away. They hunt, they flirt, they reproduce. And they do most of this while fully exposed to the air. Watching one for the first time feels wrong, almost unsettling. Even experienced biologists have admitted that the first encounter with a mudskipper feels like watching an evolutionary error that somehow survived. A fish behaving like something else entirely. Naturally, the first assumption many people make is that mudskippers must not be real fish. Maybe they are halfway amphibians. Maybe they are some strange transitional species caught between water and land. Maybe they're closer to frogs or salamanders, but they are not. Mudskippers are fully, undeniably fish. They have gills. They have fins. They have scales. Their skeleton places them clearly within the fish family tree. There's no confusion in their classification, only confusion in their behavior, which raises an uncomfortable question. How? How does a creature built for life underwater step onto land and refuse to leave? How does it breathe? How does it move? How does it survive the sun, the dryness, the gravity that water usually softens? And perhaps most importantly, why would it even try? To understand mudskippers, you have to let go of the idea that evolution follows rules. Evolution does not care about categories like fish or land animal. It does not care what looks logical to us. Evolution only cares about advantage. If breaking a rule helps survival, that rule will be broken without hesitation. Mudskippe are proof of that the biggest problem any fish faces on land is breathing. All vertebrates need oxygen, but fish extract oxygen from water, not air. Their gills are delicate structures designed to work only when water flows across them. Water keeps them open. Water keeps them moist. Water allows oxygen to diffuse into the bloodstream. Take away the water, and gills collapse. This is why most fish die so quickly outside water. Their gills dry out, stick together, and stop functioning. Oxygen can no longer pass into the blood. Suffocation happens fast. Mudskippers found a way around this problem. Actually, they found several. One of the most important adaptations mudskippers have is their skin. Unlike most fish, their skin is highly vascularized, meaning it is packed with blood vessels that run extremely close to the surface. This allows oxygen from the air to pass directly through the skin and into the bloodstream. As long as the skin remains moist. In simple terms, mudskippers can breathe through their skin. This is something we usually associate with amphibians, not fish. But mudskippers do it so effectively that skin respiration becomes a major source of oxygen when they are on land. That is why they are almost obsessed with staying wet. You will often see them rolling in mud, pressing their bodies against damp surfaces, or retreating into shallow pools. Dry skin means no oxygen, but skin breathing alone is not enough. Mudskippers also have modified gill chambers that act like built-in water tanks. When they leave the water, they trap small amounts of water inside these chambers. This prevents the gills from collapsing and keeps them functional, even while exposed to air in a strange way. The mudskipper carries part of the ocean with it. This trapped water allows the gills to continue extracting oxygen, essentially turning the gill chamber into a crude, temporary lung. It is not perfect, but it is good enough to survive for long periods on land. Breathing, however, is only half the battle. Movement is the next challenge. Most fish outside water are helpless. Their bodies are built to push against water, not air. Gravity pins them down. Their fins are useless for walking. All they can do is flop and hope for the best. Mudskippers refuse to accept that. Limitation. Their pectoral fins are muscular and jointed in a way that allows them to act more like limbs than fins. These fins rotate forward and backward, pressing against the mud and pulling the body along. The motion is not graceful, but it is effective. They don't just crawl. They leap using their powerful tails. Mudskippers launch themselves forward in sudden bursts, sometimes covering surprising distances. Some species can jump more than 2 feet into the air, an impressive feat for a fish that technically should not be jumping at all. On land, mudskippers are not weak or vulnerable. They are active, aggressive, and confident. The mudflats are not a resting place for them. They are a battlefield. Mudskippers are highly territorial, especially males. Each individual claims a section of mud as its own and defends it fiercely. When rivals approach, displays begin. Fins are raised. Bodies are lifted high. Mouths open wide in exaggerated threats. If the warning does not work, fights follow. These fights are not random. Mudskippers are capable of recognizing individual rivals. Studies have shown that they remember past encounters and adjust their behavior based on previous outcomes. A male that has lost a fight to a particular opponent is less likely to challenge that same rival again. This means mudskippers learn from experience. That alone forces us to reconsider how we view fish intelligence. They are not simply acting on instinct. They are making decisions based on memory and risk assessment. In a way, their territorial disputes resemble ranked competitions, where previous victories and defeats matter. Land life did not just change how mudskippers breathe and move. It changed how they think. Their feeding behavior also reflects the shift. Underwater, fish rely on speed, agility, and suction to catch prey. On land, those strategies no longer work the same way. Prey behaves differently. Movement is slower. Escape routes are limited. Mudskippers adapted their hunting style to match their environment. Instead of chasing prey across open water, they stalk insects, worms, and small crustaceans on the mud. They use a vacuum-like motion to suck prey into their mouths, carefully timing their strikes. Scientists have observed mudskippers adjusting their strategy depending on how wet or dry the ground is. On soft, wet mud, they lunge quickly and slurp up food. On firmer ground, they move more cautiously, sometimes waiting motionless until prey comes within range. This flexibility gives them access to a massive food supply that other fish cannot reach, while underwater fish compete endlessly for limited resources. Mudskippers step outside that competition entirely. The mudflats are full of small invertebrates that most fish never get a chance to eat. By exploiting this untapped buffet, mudskippers gain a powerful advantage. In evolution, finding food where no one else is looking can change everything. Of course, life on land comes with constant danger. The sun dries skin, heat increases water loss, predators from above become a threat. Birds, reptiles, and even mammals now enter the picture. Mudskippers respond to these dangers by staying close to the mud. Mud is their shield. They coat themselves in it. They burrow into it. They dig elaborate tunnels beneath the surface. These burrows serve multiple purposes. They protect against predators. They retain moisture. They regulate temperature. And most surprisingly, they play a critical role in reproduction. Mudskippers do not just live on land. They reproduce there too. This creates another problem. Eggs still need oxygen, but underwater burrows often lack direct access to air. The solution mudskippers evolved is one of the strangest reproductive behaviors seen in fish. The female lays her eggs inside the burrow. The male then takes on the responsibility of oxygenating them. He swims to the surface, gulps air into his mouth, dives back down, and releases the air into the burrow chamber. He literally delivers oxygen by mouth. By repeating this process, the male creates and maintains an air pocket that keeps the developing eggs alive. It is an active, deliberate behavior that requires memory, timing, and effort. Even reproduction has been reshaped by life on land, and where reproduction exists, competition follows. Some male mudskippers have developed sneaky strategies to bypass direct conflict. Instead of fighting dominant males for territory, they wait. They observe. When a female enters another male's burrow, and the owner is distracted defending his land, the sneaky male slips inside and mates with the female unnoticed. It is deception, strategy, opportunism, all from a fish. By this point, it becomes clear that mudskippers are not simply surviving on land. They are exploiting it. They are using it to escape competition, access food, defend territory, and reproduce more effectively. So why are they still considered fish? Because despite everything, they never stopped being one. They never lost their gills. They never lost their fins. They never underwent metamorphosis. They did not evolve into something else. Their closest relatives are gobies, fully aquatic fish that never leave the water. Mudskippers are not halfway. Through becoming land animals. They are fish that learned how to bend the rules, and this realization opens the door to a much larger idea, one that stretches far beyond mudflats and mangrove. Swamps. Evolution is not a straight line. It does not move cleanly from water to land and stop. It experiments. It explores. It pushes boundaries wherever opportunity exists. Mudskippers are not alone. There are walking catfish in Southeast Asia that slither across wet roads to reach new ponds. There are climbing perch that can survive days out of water, dragging themselves across land using their gill plates. There are lungfish that bury themselves in dry mud and wait for rain. Even if it takes years, the boundary between water and land is thinner than we think, and mudskippers stand right on that boundary, daring us to rethink everything we assume about what a fish can be. The more scientists studied mudskippers, the harder it became to ignore an uncomfortable truth. These fish were not simply surviving on land by accident. They were actively choosing it. Again and again, individuals were observed leaving water even when they did not need to. Even when oxygen levels underwater were stable. Even when predators were nearby. Land was not a last resort. It was a strategic decision. This raised a question that went far beyond mudskippers themselves. If a fish can voluntarily step onto land and succeed there, what does that say about the limits of evolution? For a long time, the story of life moving from water to land has been told as a dramatic, one-way journey. Ancient fish slowly developed limbs, lungs replaced gills, and eventually reptiles, mammals, and humans emerged. The idea suggests a clean break, a clear transformation from one category into another. Mudskippers complicate that story. They are not ancient fossils. They are alive right now, and they show that moving onto land does not require abandoning the water entirely. It can be partial, flexible, reversible. Mudskippers still depend on water, but they no longer let it control them. One of the most fascinating aspects of mudskipper behavior is how finely tuned they are to environmental conditions. They constantly measure moisture, temperature, and oxygen availability. When the mud begins to dry, they retreat. When the tide comes in, they may stay out longer than expected, using their burrows as safe zones. Their decisions are not random. This suggests something important. Life on land demands awareness. In water, oxygen is everywhere, movement is supported, and temperature changes more slowly. On land, everything is unstable. Oxygen is plentiful, but dryness threatens survival. Heat fluctuates rapidly. Predators attack from above instead of all directions. Mudskippers behave like animals that understand this instability. They adjust their posture to reduce water loss. They orient their bodies to the sun when basking, warming themselves without overheating. They retreat into burrows when conditions become too harsh. Each choice increases survival just a little, and in evolution, small advantages add up. Their eyes offer another clue to how deeply land has shaped them. Unlike most fish, mudskippers have eyes that sit high on their heads, capable of rotating independently. When they are underwater, the eyes retract slightly. When they are on land, the eyes rise, giving them a wide field of vision above the surface. This is not accidental. Seeing above water is critical for detecting predators and rivals. Birds, in particular, are a major threat. A fish that cannot see upward is a fish that will not last long on land. Mudskippers solve this problem by turning their heads into periscopes. They even blink. Not with eyelids like ours, but by pulling their eyes down into fluid-filled sockets to keep them moist and clean. It is another small adaptation, but one that makes extended time on land possible. Every part of their body tells the same story: compromise. Mudskippers did not replace old systems with new ones. They layered new abilities on top of old ones. Gills still work. Fins still function. But additional tools were added where needed. This layered approach explains why mudskippers are so successful in environments that sit between land and water. Mangrove swamps and tidal mudflats are unstable places. Water comes and goes. Oxygen levels fluctuate. Predators change with the tide. Most animals struggle here. Mudskippers thrive. They time their activities with the tides, emerging when mudflats are exposed and retreating when water returns. This rhythm reduces competition and danger. When fully aquatic fish dominate, mudskippers step out. When land predators increase, they slip back into the water or their burrows. They exist in the gaps, and that is where evolution often does its most creative work. Competition is another driving force behind their strange behavior. Underwater, fish compete intensely for food, shelter, and mates. Space is limited, and dominance hierarchies are brutal. By moving onto land, mudskippers escape much of that pressure. The mudflat becomes an extension of their territory that other fish cannot access. This freedom allows them to spread out, establish clear boundaries, and reduce constant conflict. It also allows sexual selection to operate differently. Displays on land are more visible. Body size, posture, and aggression can be assessed more easily. Females can observe males without being swept away by currents or obscured by murky water. This may explain why mudskippers invest so much energy into visual displays. Raised fins, bright coloration, exaggerated movements, all of these make more sense in air than in water. Land changed how mudskippers compete for mates. It also changed how they protect their young. The burrows they build are not simple holes. Many species create complex tunnel systems with multiple chambers. These structures regulate temperature, humidity, and oxygen. Some even have sloping entrances to prevent flooding during high tides. Inside these burrows, eggs are protected from predators and environmental extremes. The male's role in maintaining oxygen levels shows a level of parental investment that is rare among fish. He must repeatedly travel between the surface and the nest, timing his movements carefully. If he fails, the eggs suffocate. This behavior did not evolve overnight. It likely emerged gradually, as individuals that stayed near their nests and manipulated air survived better than those that did not. Over generations, the behavior became more refined, more efficient, and more essential. Mudskippers are living evidence that complex parental care is not limited to mammals or birds, but despite all this complexity, mudskippers are still constrained by their fish origins. They cannot fully escape water. Their skin must remain moist. Their gills still require water. Their eggs eventually hatch into larvae that drift in water. Before settling back onto mud. This creates a ceiling. They can push toward land, but only so far, which leads to the question scientists cannot resist asking: could that ceiling ever break? If environmental pressures increased, if mudflats expanded, if predators changed, if competition underwater became unbearable, could mudskippers continue moving toward a fully terrestrial lifestyle? At first glance, the idea seems tempting. After all, ancient fish once made a similar leap. Given enough time, could mudskippers repeat that history? The answer is complicated. Evolution does not work toward goals. It does not plan for the future. Mudskippers are not trying to become land animals. They are responding to immediate pressures. Any move toward full terrestrial life would require massive changes. True lungs would need to replace gills. Skin would need to become resistant to drying. Reproduction would need to occur entirely outside water. Skeletons would need to support body weight without buoyancy. These are not small steps, and there is no guarantee that such changes would provide enough advantage to outweigh the costs. For now, mudskippers occupy a sweet spot. They benefit from land without abandoning water. They exploit two worlds instead of committing to one. This flexibility may be exactly why they are so successful. In many ways, they represent an evolutionary strategy that is often overlooked, not transformation, but balance. This is why mudskippers are so valuable to science. They are not just curiosities. They are living laboratories. By studying them, scientists gain insight into how early vertebrates may have experimented with land before fully committing to it. They show that evolution is not always about dramatic leaps. Sometimes it is about standing with one foot in the water and one on land, waiting to see which direction offers the greatest advantage. And this idea reshapes how we think about adaptation itself. Mudskippers remind us that nature does not care about our definitions. Fish is our label, not evolution's. What matters is survival, reproduction, and efficiency. If crawling onto land helps a fish survive, then land becomes part of its world. The mangrove swamps, once thought of as harsh and limiting, become arenas of opportunity. Every exposed mudflat becomes a chance to feed, fight, and reproduce with less competition. What looks like a nightmare environment to us becomes a playground for them. This ability to see opportunity where others see danger is one of evolution's most powerful forces. And Mudskip. When people talk about evolution, they often imagine it as something that happened long ago. Ancient oceans, primitive creatures, a distant past that no longer touches the modern world. Mudskippers shatter that illusion. They are not fossils. They are not relics. They are alive, active, and changing right now, every time a mudskipper pulls itself out of the water. Evolution is not being remembered. It is being demonstrated. What makes mudskippers truly remarkable is not just what they do, but what they represent. They exist in a space most animals avoid, the space between environments. Neither fully aquatic nor fully terrestrial, they live in uncertainty. And yet, that uncertainty is exactly what gives them power. Nature rewards those who can tolerate instability. Mangrove, swamps, and tidal mudflats are constantly shifting. Water levels rise and fall. Oxygen levels change. Temperatures swing. Predators appear and disappear. Many animals struggle to cope with even one of these variables. Mudskippers handle all of them at once. They do this not by specialization, but by flexibility. Flexibility is often misunderstood. It does not mean being average at everything. It means being good enough at many things to exploit opportunities others cannot. Mudskippers breathe through skin, gills, and trapped water. They move by crawling, jumping, and swimming. They feed on land and in water. They reproduce using air and mud. No single adaptation defines them. It is the combination that matters. This is why mudskippers are so difficult to place in neat categories. They are fish that behave like land animals without becoming land animals. They are reminders that evolution does not always create new forms by replacing old ones. Sometimes it stacks solutions on top of each other. One adaptation leads to another. One behavior opens the door to the next. And slowly, a creature becomes something that feels impossible. Looking at mudskippers forces us to confront a deeper idea. The transition from water to land was not a single event. It was not a moment where fins suddenly turned into legs and gills into lungs. It was a long period of experimentation. Many experiments failed. Some survived only briefly. A few, like mudskippers, found a stable balance and stayed there. In that sense, mudskippers may resemble what early vertebrates once were, not direct ancestors of land animals, but cousins experimenting with similar challenges. They show us what the early stages of land exploration might have looked like. Awkward movement, partial breathing solutions, a reliance on moisture, heavy dependence on specific environments. They also show us why full terrestrial life took so long to evolve. Land is unforgiving. Water supports body weight. Land does not. Water keeps tissues moist. Land dries them out. Water hides animals from gravity and heat. Land exposes everything. Mudskippers survive on land because they never fully leave water behind. Their burrows remain damp. Their skin stays wet. Their gills stay functional. Remove those safety nets, and their success collapses. This tells us something important. The reason most fish never follow the mudskipper's path is not because it is impossible, but because it is risky. Every step away from water increases danger. Evolution only moves forward when the benefits outweigh those risks. For mudskippers, the benefits are clear. Less competition for food, more control over territory, better visibility for mating displays, reduced pressure from aquatic predators, access to resources that no other fish can exploit. As long as those benefits remain, mudskippers will continue walking the line between worlds. But evolution never stops asking questions. What happens if the environment changes? Climate shifts, rising sea levels, and habitat destruction could reshape mangrove ecosystems. Mudflats may shrink or expand. Predators may change. Competition may increase. New pressures could push mudskippers in unexpected directions. They might retreat back into water. Or they might push further onto land. Both are possible. Evolution has no preferred outcome. This uncertainty is what makes mudskippers so valuable to scientists. By studying their physiology, Behavior and genetics, researchers can understand which traits make land tolerance possible and which limitations remain hardest to overcome. Mudskippers help answer questions that fossils cannot. They show how behavior often evolves before anatomy. Walking came before legs. Air exposure came before lungs. Territorial displays on land came before full terrestrial reproduction. Behavior opens doors. Anatomy follows later, if it ever does. This pattern appears again and again in evolution. Animals test new behaviors first. If those behaviors provide enough advantage, natural selection begins shaping the body to support them. If not, the behavior disappears. Mudskippers pass the first test. Whether they pass the next remains unknown, but perhaps the most important lesson Mudskippers teach us is not about the future. It is about how we see life now. Humans love categories. Fish, amphibians, reptiles, mammals. We draw lines and expect nature to obey them. Mudskippers ignore those lines completely. They do not ask permission to exist where they shouldn't. They simply do. They remind us that nature is not clean or organized. It is messy, experimental, and endlessly creative. Whenever there is an opportunity, no matter how strange life will try to fill it, a muddy shoreline that dries twice a day becomes a new frontier. A fish turns it into home. In the end, Mudskippers are not anomalies. They are examples. Examples of what happens when survival rewards boldness, when adaptation favors curiosity over comfort, when evolution finds an edge and pushes against it again and again. They are fish that walk, breathe air, fight on land, raise their young in burrows, and exploit a world most of their relatives cannot survive in. They are not breaking nature's rules. They are revealing how flexible those rules really are. And as long as tides continue to rise and fall, as long as mudflats exist between land and sea, Mudskippers will keep doing what they do best, standing at the border of two worlds, reminding us that evolution never truly stands still.